Alright, let's look at the homework 4.5, problem number 8. We want to sketch the graph of y equals arctangent of x minus 1 over x plus 1. Alright, so let's do that. Alright, first we're going to look at the original function here, number 1. We look at y, right? Then domain would be, let's see, if you since there's a x plus 1 on the bottom, so we don't want x to be negative 1. So, but other than that, I think it's always defined. So the domain is going to be all real numbers except for 1. So I'm going to have 1 and then skip 1 and go to positive infinity, right? Then we have to examine what happens to the function near 1. So I'm going to look at the limit of this function. So arctangent of x minus 1 over x plus 1 as x approaches, actually I messed it up, so it's a negative 1, right? So it's a negative 1, say, from the positive side. Right? So if x approaches negative 1, so you have a negative 1 minus 1, so it's negative 2. And here is the negative 1 plus 1 from the positive side, so it's going to be positive 0. So this is going to be, it's going to approach negative infinity. Right? So if you have an arctangent of negative infinity, so this is going to head toward the negative pi over 2, right? And if you do the same thing, limit of arctangent and of x minus 1 over x plus 1, if x approaches negative 1 from the negative side, and you can see that this guy is going to approach positive infinity, right? Then if you look at the arctangent, it's going to have positive pi over 2, right? So as x approaches negative 1, from positive side it goes to negative pi over 2, and from the negative side it goes to positive pi over 2. So we got that. Alright, then let's look at the maybe intercepts. Alright, so let's see, if you plug in 0, alright, so it's going to be y equals, let's see, y-intercept. Alright, so we're going to set x equals 0, so it's going to be y equals our arctangent of, let's see, 0 here, negative 1 over 1, negative 1. Right, which is, let's see, arctangent of negative 1 would be negative pi over 4. Alright, so we got that. And then x-intercept is going to be, alright, we're going to set y equal to 0. So we set the arctangent of x minus 1 over x plus 1 equals 0. Alright, so in order to make arctangent 0, so we have angle has to be equal to 0. So you're going to have, let's see, x has to be 1. So here, x equals 1. Alright, and I think that's all we can do. So what we're going to have, we'll have to look at the first derivative, y prime. Alright, derivative of that. So y prime is going to be, derivative of arctangent is 1 over 1 plus x squared. So you're going to have 1 over 1 plus x, but you have an inside function, which is x minus 1 over x plus 1 squared. Then multiply by derivative of the inside function. So derivative of x minus 1 over x plus 1 is x plus 1 squared on the bottom, and the derivative of the top is 1 times the bottom, so which is x plus 1, minus the top, x minus 1 times the derivative of the bottom, which is 1. Alright, then you can see that we can cancel here x minus x, then you have a 1 minus negative 1, so it's going to be 2. Then I'm going to distribute this guy to each of these terms, and you end up getting this. Alright, so you have 2 on top. Alright, then you have x squared plus 1. Sorry, not x squared plus 1. X plus 1 squared. Alright, plus. Alright, so the denominator cancel out. So you're going to get x squared minus 1. I messed it up again. X minus 1 squared. Alright, this can be simplified to 2 over. Right? So this is x squared plus 2x plus 1 plus x squared minus 2x plus 1. So we can cancel positive 2x and a negative 2x. And you have a 2x squared and a 2 1s. So we can cancel that with 2. So it's 1 over x squared plus 1. Right? And this tells you that, again, this guy is always positive, right? So this tells us that y is always increasing, right? Then we can look at the second derivative, right? So y double prime, right? So y double prime would be, y double prime is going to be equal to, right, we can use quotient rule, square the bottom, x squared plus 1 squared. And derivative of 1 is 0, so it's going to be minus top 1 times derivative of the bottom is 2x. Right? So you have just a negative 2x over x squared plus 1 squared. And to set that equal to 0, we know that the x equals 0. Right? So if you draw a number line here, alright, then you have, here's a 0. Alright, then the domain exclude negative 1, so we put the negative 1 here. Right? Maybe I'll put the open circle there. So let's see. So here's an open circle, and I'm going to use white to white that out. Alright. Alright, then we can look at the increasing, decreasing behavior. So y prime, it's always positive, so it's always increasing. So it's increasing here, and increasing here, and increasing there. Alright. Then y double prime says that, so it's before 0. Looks like we plug in negative 1 or something like that, so it's a negative times negative positive, bottom is always positive. So it looks like it's concave upward here and concave upward there. Right? After that, if x is positive, second derivative is negative. Alright, so we know that the graph is going to have a shape here, increasing and a concave upward. So you have increasing and concave upward. So it's going to look like kind of like this. And then after that, it's increasing concave upward. So it's going to look kind of like this. And after that, it's increasing and concave downward. So it's going to look like this. Right? So let's try to sketch a picture here. Right? And here's the x-axis, and here's the y-axis, right where x equals 0, right here, and x equals 0 here. All right, so let's look at the x equals -1, so right here. All right, so graph is heading toward, let's see, if you're coming from the positive side, negative pi over 2. So here I'm going to put the negative pi over 2. And here's the location. All right, so we have that. And I put an open circle because the function is not defined there. But if you're coming from the left, it's pi over 2, positive pi over 2. So I'm going to put positive pi over 2 here. And we're going to head toward this point right there. All right. Then we're going to look at the shape. Let's see. And we're going to have, let's see, y-intercept is negative pi over 4. So you have to go through here. Right? So that's negative pi over 4. And then x-intercept is positive 1. So we're going to have positive 1 is probably around here. Right? All right, so let's try to sketch a picture here. So we have here, it's going to be concave up and increasing. And it's going to look like that. After that, it's concave down and it's still increasing. So it's going to look like that. All right, then here it's increasing and a concave up, so it's going to look kind of like this. All right, so let's see if we have a graph which looks like that. So here, all right, looks like, let's see, not this one, but the second one looks very promising. So let's see. All right, so this is the picture. All right, it's very close. So second one, obviously not the third one, not the fourth one. All right, so let's double check. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.